All right, we're going to look at this idea of an average rate of change. So while we will go into slope when we do linear functions specifically, this part of the textbook just has us doing average rate of change of like any kind of function. So let's do a quick mini slope review here. All right, so slope from a graph is going to be our rise over our run. And I go based off of direction, so I'll do the sign first. So if a line is facing this way, it's positive. If a line is facing this way, it's negative. So in this first one, it's in the positive direction, and I'm just going to find the rise and run between these 2 points and simplify if I need to. So 1, 2, 3 over 1, 2, 3, 4. So we have a slope of 3/4. All right, the second one, we have a negative sloping direction, and then I can do my rise and run. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. So 8/4, which reduces down to 2. So my slope is -2. And then I have a horizontal line here. Notice I don't have anything here, right, for that. So a rise of 0 and a run of, doesn't matter, 1, 2, 3, 4, 5, 6, 7, 8. 0/8 is still 0. So a horizontal line gives a slope of 0. There was no change, right? So, and then from 2 points, probably learned it as y2 minus y1 over x2 minus x1. I do it left to right. So it's just the difference in the y's, so 3 minus -7, over the difference in the x's. So because I started with the left, I have to start with the left. So -9 minus -5. So I get 10 over -4, which reduces to -5/2, right? So y minus y over x minus x. So 3/9, which reduces to 1/3. And then y minus y over x minus x. Negative over negative will be positive, and they're both divisible by 4, so 2/3. All right, so we're going to use that idea of finding it from a graph or finding it from 2 points to find what's called an average rate of change. Okay, so in a linear function, the slope is the same throughout the whole line. Well, in this first one, we're just talking about functions in general. So not all functions are going to have a constant slope, right? So we're just finding that average rate of change. So that is just the slope of the line that passes through those 2 points, as you can see in this picture here. And that line is called a secant line, right? So to find any average rate of change between any 2 points, A and B, or any interval A and B, we would have the slope of that secant line is the difference in the y values. So, all right, let's see. I have this point. I'm not sure what it is, but it's B, and then f of B, right? Whatever the function value is. And similarly, we have A and f of A. So if I'm talking difference in the y's and difference in the x's, right? That's going to be f of b minus f of a over b minus a. Could do it the other way, f of a minus f of b over a minus b. But this is the common way I've seen it. So we are going to just do some examples here, right? So here's a graph. And we have an interval from -2 to 1. So -2 to 1, which is right here. So if I were to make that a line, I could find the rise and the run. I like to use the actual numbers instead of counting. So the ordered pair would be -2, 1, and 1, 1, 2, 3, 4, 5, 6, 7, 8, -8. So y minus y over x minus x. And that's going to give me 9 over -3, so a slope of -3. And then I can do the same thing, 0 to 4, so 0, and then 1, 2, 3, 4. So I want the slope between those 2 points. And again, I get the ordered pairs. So 0 and, was that 7? And then 4 and 1. So y minus y over x minus x. Oh, was that right? 1, 2, 3, 4, 5, 6, 7. Oh, that's a -7. So -8 over -4, which is a +2. So you can see that 2 different intervals on the same function produced a different slope. So, so I call it an average rate of change on an interval. All right, what if we just had equations instead? So, all right, we just have to evaluate them, right? So f of -1 is going to give, what is that, -7, so -21, and then plug in 2. So then I have my ordered pairs. I'm just going to write them here. -1, -21, and then 2 and -6. So y minus y over x minus x. Should be minus -6. So -15 over -3 to give me 5. Right, we do the same thing here with all of these, and we will. These are big numbers. So f of -9 and -7. And I'm going to have to use a calculator for that. So it's going to be 81 times 2 minus 28 times 9 plus 93. So it gives me 3. So -9, 3. And then was that 49 times 2 minus 28 times 7 plus 93. So -5. So then I have y minus y over x minus x to give me 8 over -2, which simplifies to -4. All right, substitute all of this in. Then I have to get my calculator back out. So let's see, 4 cubed, and then 4 squared is 16. 16 times 2 is 32, minus 36 plus 1. So I get -3. Oh my gosh. 7 cubed, I don't know that. 7 times 7 times 7. 343 minus 49 times 2 minus 63 plus 1. I get 183. So then y minus y over x minus x. And is 186 divisible by 3? Let's find out. Oh, it is. 62. All right, evaluate these. All right, 2 to the 4th. I believe is 16. And then, so we have negative 16 plus 12 minus 17, so negative 21. And then 5 to the 4th. So negative 625 plus 25 times 3, 75. And then minus 17. Gosh, these are some big numbers. So that's what? Negative 2, negative 21. That's 5, negative 567. So y minus y over x minus x. And is 546 divisible by 7? Oh my gosh, it is. 78. And these ones should be a little bit easier. 2 minus 4 over 2. 2 minus 4 is negative 2. Negative 2 over 2 is negative 1. And then what about 8? Ooh, is this going to be a fraction? 8 minus 4 is 4. 4 over 8 is 1/2. So y minus y over x minus x. That's a negative 3/2 over, what was that, negative 6? I can make that negative 6 over 1 and then do big C over little c and make that negative 3 over negative 12, which is going to reduce to a positive 1/4. And then we got this last one before some word problems. So f of negative 1. Negative 1 plus 5 is 4. Square root of 4 is 2. And then 7. 7 plus 5 is 12. Square root of 12 is not a fun one. It's okay. We'll make it through. Y minus y over x minus x. I feel like I could reduce that 12. Let's see, 4 and 3. So that's going to give me 2 minus 2 root 3 over negative 8. I can reduce all those by 2. So 1 minus root 3 over negative 4. I'm sure that'll come out to some decimal, but that's going to be good enough. All right, so let's apply it here. So, company's total cost, C of x, in dollars to manufacture X units is given by C of x is 0.05x squared plus 40x plus 1200. Find the average rate of change of the total cost for the first 200 units manufactured. So the interval we have here is the first 200, so from 0 to 200. So luckily, if I do C of 0, right, it's going to knock out those first two terms, and it's going to leave me with 1200. So 0 and 1200. Now I just have to evaluate C of 200. And that I need a calculator for. So let's see. 200 times 200 times 0.05 plus 40 times 200 plus 1200. It's going to give me 11,200. And then I can do a y minus y over x minus x. So I get a negative 10,000 over negative 200, which that will come out evenly to be 50. So in terms of context, right, it's going to be 50. The y value is in dollars, so $50. And then per x, which is units. So $50 per unit. And a ball is thrown straight upward so that its height, h of t, in feet, is given by the equation h of t is negative 16t squared plus 80t, where t is time in seconds. Find the average rate of change in the height of the ball from when it reaches its maximum until when it reaches the ground. Right? All right, so visually, ball is thrown upwards, is going to come back down. So our interval is the maximum to where it hits the ground. So let's do some things. You should know how to find the maximum of a quadratic by this point, but we do have a quadratics unit. So I'm going to assume you don't know how to do that. So we're going to plug that in a graphing utility, and we're going to get that maximum. So negative 16t squared plus 80t. That maximum is 2.5 and 100. And because I'm already in my graphing utility, I'm going to go ahead and get the 0 as well. Well, I'm gonna do this a couple ways, because yes, I can find it in my graphing utility, right? But I'm gonna do something. So the quadratic, that maximum is the halfway point. So if I started at the ground and went 2.5, it's going to hit the ground because of the symmetry here. It's going to hit the ground in another 2.5. So that's going to be at 5. Or we can factor. So negative 16t squared plus 80t. I can factor out a negative 16t and be left with t minus 5. So my zeros are going to be 0 and 5. Okay, right? Because that would set that equal to 0. So, all right, my interval is from 2.5 to 5. And I know what my value is. So I have 2.5 and 100. And then my other value is 50. So if I do y minus y, so 100 minus 0 over x minus x. So 2.5 minus 5. So it's going to be 100 divided by negative 2.5. And 100 divided by negative 2.5 is a negative 40. And then in terms of our context, right? Because context matters. Our y value is in feet, so negative 40 feet. And then t is time in seconds. So negative 40 feet per second. And that is all I have for the average rate of change. So if you have any questions, let me know.